Folks, we keep trucking on, and in this video, and maybe the next one, we're going to talk about the dilution equation. Dilution is the solution to pollution, right? You often hear us say that in a laboratory, by the way. If something's kind of toxic, or if something shouldn't be maybe dumped in very high concentrations, dilute it, and then you can pour it down the drain. Now, the dilution equation is no more difficult than molarity. Actually, I think dilution is a little easier. So if you can do molarity, you should be able to handle dilution quite well, because the equation is a little simpler. And the equation is MV equals MV. Now, here's the deal. The M typically stands for molarity. And the V typically stands for volume. And the reason I'm presenting the equation this way is because if you've taken Chemistry 151, then they probably have told you this garbage. And they have said, well, you need molarity in order to use dilution, and if you don't have molarity, you can't solve it. But guess what? You don't need molarity for this dilution equation to work. It's like a whole new world just opened, isn't it? The same way with volume. Now, notice it says volume. It doesn't say liter. I don't need liter for this equation. As long as my units are staying the same on both sides of the equation, then I'm good. So I need to rewrite the equation. And the way that I'm going to present it to you is CV equals CV, where C stands for concentration. It can be any concentration that it wants to be. It can be molarity. That's fine. But, you know, it can be parts per billion. It can be parts per million. It can be a percentage. It can be a percent weight by volume. It can be a percent volume by volume. It can be anything that it wants to be, people. As long as we're talking about a concentration, this equation will work. Bottom line. So what makes this equation a little simpler is that I don't really have to worry about converting units from one to another, right? If they're giving me milliliter, my answer better be in milliliter. If they're giving me liter, my answer better be in liter. If they're giving me molarity, my answer is going to be in molarity. If they give me parts per million, my answer is going to be in parts per million. Doesn't matter. And then if I need to take an extra step to convert that over to a different unit in the very end, I can. But it's not necessarily to plug them into the equation. Okay, so dilution. Why do we use dilution? Well, for dilution, that typically means that we already have a very strong solution. All right? And that very strong solution needs to be weakened down. So again, go to the bartender, order a mixed drink, it brings it back, you take a sip, it's too strong, you send it back, you tell them to weaken it. They're going to dilute it down. They're probably going to add more mixer, they're going to add more non-alcohol related stuff to that drink. The same way with Kool-Aid, for those of you that are not over 21, right? If you take a sip and it's too sweet, then you're probably going to go back and you're going to add more water to it, and you're going to weaken it down. It's not going to be as sweet anymore. So that's the dilution equation. There's a whole science behind it. Okay, so a strong solution that needs to be weakened down. This is how it's different than molarity. So molarity is taking a solid and it's dissolving it into a liquid to make a solution with, right? With the dilution equation, we're taking a liquid already made, a solution that's already been prepared, and we're weakening the concentration of the solution. And that's the abbreviation that I use for concentration, bracket X. All right, so for instance, let's say that we go into the laboratory and the lab has a 12 molar solution of hydrochloric acid. That's way too strong for us, right? So what needs to happen is that I need to make a weaker solution based on the lab procedure that I'm following. And my lab direction says that I need to make a 3 molar solution. And it gives me a volume to make. It says you need a 3 molar solution and you need to prepare 500 milliliters of that solution. That way it prevents waste, right? Okay, well, in order to figure out how to do this, I'm going to take CV equals CV. Now, there's typically ones here and twos here, or I's and F's, depending on who taught it to you. The ones basically mean initial, the twos basically mean final. That's where you want to end up and where you start with. Okay, so the original concentration in the beginning is 12. The volume, I don't know how much of that to use, so that's going to stay as an X or V, if that's what you want to keep it as. This is the concentration that you want to end up with. The concentration that I want to end up with is a 3 molar. And then that volume is what you want to end up with. And it says I want to end up with 500 mils, so 500 is going to go there. Remember, I told you, unit doesn't matter. Molarities can be used, milliliters can be used. Who cares? It's a free-for-all. All right, so 12 times X is 12X. And then 3 times 500 is 1,500. Then I'm going to pull up the calculator and I'm going to solve for X. So in order to solve for X, that's 12 times X. I'm going to divide by 12 to get the variable by itself. So that means 1,500 divided by 12 equals 125. So X is equal to 125 milliliters. Well, that means I'm going to take a volumetric flask in a laboratory and I'm going to go to my 12 molar solution, right? And I'm going to pipette or measure out 125 milliliters of that stuff. So in it goes, 125 mils. And then I'm going to weaken it down. And what happens is that I add water up to the neck of the line, if that's my solvent, right? Water's typically the solvent, not every single time, but in this case it is. I'm going to add enough water till I get to the 500 milliliter mark. Now you got to pay attention to how these questions are stated. So some of the questions will say, how many milliliters of the original solution do you need to use? So 125 mils, right? To make a total of 500. So another part of these questions could be, well, how much solvent do you need, right? If you have 125 mils of acid that you're using here, and you need a total of 500, then I just subtract these two things, right? And when I subtract these two things, I'm going to get 375. So the actual milliliters of solvent that I need to mix in is around 375 milliliters. If everything dissolves in each other perfectly like textbook is supposed to be, I'll take 375 mils of water and I'll add 125 mils of a 12 molar HCl solution, and that gives me a total of 500 milliliters. But here's the key. I'm typically not going to ask those types of questions. I think that's more confusing than what it needs to be. Because in a laboratory, that's not what you would have to worry with. In a lab, what you would worry with is getting a 500 ml volumetric flask, adding 125 mils into that flask, and then diluting up to the line with water. That's all that you got to do. As long as you have the volumetric glassware that's proper, then these equations or these questions should not be any more difficult than that. And your job as an analyst should not be any more difficult than that. All right? Okay, so let's take a look at another example. So let's say I go into the lab and I have a salt solution, and that salt solution is made at 20%. And let's say I want to weaken that down. That's way too strong for me to use. So I'm going to weaken it down, and I want a 5% solution, but I don't want to be wasteful, and I only want to make 150 milliliters of that substance, right? How would I do it? Okay, well, I'm taking something stronger and I'm making it weaker. This is a liquid already, and it's still a liquid in the end, so I'm going to dilute it. Dilution is the solution. All right, so the initial concentration is 20, and that's 20%, right? Well, just plug in that number. I don't need to convert that or anything. Just put it in, 20. Just pretend like it's molarity or ppm or ppb, whatever the unit is. Just plug it in. The V, I don't know how much of that to use. The concentration I want to end up with is a 5. And the volume is 150 milliliters. All right, so I'm going to take 20 times x, which is 20x. And then I'm going to take 150 times 5, right? So 150 times 5 is 750. Notice I dropped the percentage. I don't need to do anything with the percentage. It's just a unit. That's how you need to think of it. It's just a unit. Don't do anything with it. Don't do anything crazy. You're overthinking it if you want to convert that to a decimal. Do not do it. Just pretend like it's an M and plug the numbers into the equation. And then finally, 750 divided by 20 equals 37.5. So X is equal to 37.5. 37.5 what? Well, that's milliliter. So therefore, my answer is in milliliter because that represents volume, right? That represents volume. There's my volume. The units have to match. So what I would do is I would take a volumetric flask, 150 mils, if I can find one that does that. I don't think there is, but there could be. And then I'm going to add in 37.5 mils of a 20% solution. And then on top of that, I'm going to bring in some solvent, probably water in this case, and I dilute up to the line, mix it, make sure it fully dissolves, make sure it's miscible, and then my solution prep is done, right? Now, here's the kicker. My advice to you is number 1, you do not add to the line before mixing. What that means is that I want you to add a little bit. So just maybe go up to here with some water. Swish it around, stir it, make sure that it's mixed. Turn it upside down a couple of times, right? Go ahead and mix this solution up pretty well. And then take it on up to the line after you feel that it has fully became miscible with each other. Do not add it to the line before you mix it. If so, you could actually go over the line because some liquids take up more room when they mix together, believe it or not. And some liquids will actually shrink. They dissolve so well with each other that when you mix them together, the volume will be lower than the meniscus line. And you'll have to go and add a little bit more water in order to get it up to the line that's on the volumetric flask. So that's how we solve for dilution. That's all there is to these problems, right? It works with any concentration. It works with any volume. Just plug the numbers into the equation and you've got it, people. All right. So I'm going to do one more. This time, let's say that we go to Lowe's and we buy a 9.5% bleach solution. All right, and let's say that I'm required to make a 5% bleach solution, and I'm getting ready to clean some floors or clean some countertops. So let's say I need 20 liters of this stuff. So how many liters would I need to use of the 9.5? All right, so CV equals CV. Concentration I'm starting with is 9.5. I need to know how much of that to use. I want to end up with a 5, and I need 20 liters of that stuff. All right, so I'm going to take 20, and I'm going to multiply by 5, and I get a 100. So 100 is going to go here, and then 9.5x. So I'm going to take a 100, and I'm going to divide that by 9.5, and I hit enter, and I get 10.53. So x is equal to 10.53. Well, x here represents volume, right? And my volume in this question was provided in liters. So my answer is in liter. So 10.5 liters of stuff, 9.5% bleach. I'm going to put that in a big old bucket. And then I'm going to add up to the line until I get to 20 mils in total with water. And I have successfully diluted my solution. The only extra step that you might see is if the problem doesn't want liter, but let's say milliliter instead. That might require an extra conversion. And I think that you can do a liter to milliliter conversion at this point, right? So you just got to pay attention to what the question asks for. Do they want to be in liter? If so, that's great. No big deal. If they want it in milliliter, you got to take that extra step. You got to go on, use that conversion, 1,000 mils in a liter, and report your answer that way. So good luck on the dilution problems. Really, this is all there is to it. It's not complicated. It's not rocket science. Can you use the CV equals CV equation? Just keep in mind, any unit will work and any volume will work as long as they're the same on both sides of the equation. So you should be able to pop these questions out without a problem. You could probably do it blindfolded.